Hi, everyone. I'm Jess, a backend engineer at a medtech startup called Scan.com. I'm Canadian from Ottawa, but I live in the UK and work on the US side of the business, which basically means I'm never quite sure how to spell words like color, center, and gray. I created this talk after volunteering as a mentor at a Rails Girls event. The women I was paired with had some fantastic questions about what we were building. Some I could answer and some I couldn't. That made me want to dive deeper into Rails, specifically ActiveRecord, so I could answer her questions a bit better the next time around. Today I'm sharing what I learned through the lens of Zoe, a fictional character inspired by the women I met that weekend. We'll be starting from the ground up with minimal assumed knowledge, just like Zoe, so this talk should feel approachable to everyone in the room, no matter what your experience level is. For the more senior folks here today, I invite you to listen with a mentor's mindset. As Zoe explores the codebase, think about which of her discoveries might be useful for the junior engineers on your team, and how you might explain concepts when you're pairing. Stick with me though, as I'm hopeful that there'll be something for you here too. Without further ado, this is ActiveRecord Unveiled, Mastering Rails ORM. And don't worry if you're not sure what object relational mapping means, we will get there. This is Zoe. She's learning to code and attended a recent Rails Girls event, where she went from knowing nothing about Rails, very little about code even, to building an entire web application using Ruby on Rails, all in one day with the help of a mentor. Rails Girls has a really handy guide that Zoe followed, and the code we'll see today is the result of her time at the event. Rails, Zoe learned, is a web application framework written in Ruby that enables developers to quickly build and maintain web applications with minimal configuration. Zoe used Rails New to create the app, and Rails Generate Scaffold to create a model, view, and controller for her ideas. There was other code involved too to add photos, and she improved the styling using Bootstrap, but overall she was really impressed by how little code she actually needed to write, with Rails Magic doing so much for her. By the end of the day, she was able to create new ideas for her dog Cody with a photo. She could edit the idea and delete the idea as well. When she was done creating and editing all her ideas, she could see them listed on the index page in case she ever needed inspiration for what to do next with Cody. But where did those ideas live in her application? When she created a new idea, she entered a name, description, and uploaded a picture. But where did it go? She did a global search, which is a search that looks in every file in the application to see if recreate scene from The Lion King appeared in any of her files, but no such luck. It turns out that information about her ideas is stored in a database, and that cylinder is the symbol for database. A database is like a digital filing system that helps Zoe store, organize, and retrieve information efficiently. Zoe learned that the data for her ideas was being stored very similarly to a spreadsheet, using columns and rows to arrange the data, and that it was a relational database. Relational databases, as it turns out, are one of the most popular types of databases. They store and provide access to data points that are related to one another. Zoe only has one table at the moment, but she has visions of being able to filter through all her ideas using different tags. Her relational database could enable her to do this. She could create a tag table with all the tags that she wants to use for filtering, but that doesn't help her yet. The two tables don't relate to each other. She would need to create a join table, an idea tags table, that stores the IDs of the database entries that relate to each other, hence the name relational database. The first entry in the idea tags table has an idea ID of 1, which is exercise Cody, and a tag ID of 2, outdoors. The next two entries in the idea tags table both have an idea ID of 2, recreate scene from The Lion King. The first entry, appearing for the second time, is outdoors with a tag ID of 2, and the last one is tag ID 3 for training, because there are actually a lot of sheep around, making a lot of sheep sounds, so keeping the sheepdog on a big old rock was very difficult. But how did recreate scene from The Lion King get from the database to her shiny new website? Zoe continued her learning and discovered that her database was a SQLite database, and something magical called ActiveRecord was enabling her to interact with the database in her favorite language, Ruby. ActiveRecord, she learned, comes out of the box with Rails, so it's been there, acting like a bridge between her Ruby code and her SQLite database. To talk about ActiveRecord, she learned, is to talk about object relational mapping, or ORM for short. So ActiveRecord is basically, she understood, like a translator. Zoe gets to write her Ruby code to get information from the database, and ActiveRecord does what it needs to do to retrieve that information and send it back to her in a format she can use. Zoe's seen this in action in the codebase, in the console. If she wanted to see all the ideas she had in her database, she could use idea.all and output her ideas. They're displayed in a really nice, user-friendly way. Since she used a variable to store all her ideas, she can find out what its class is, which is an ActiveRecord relation. So ActiveRecord is certainly hard at work here. And she can do other things with her ideas, like count them and query them using where. These are all examples of reading from the database, but ActiveRecord enables her to create, update, and delete ideas, which she's already tested on the website. Zoe notices the SQL output in the dark blue text. It's a clear view of what the database is doing in response to her Ruby code. ActiveRecord translates her Ruby commands into SQL queries, making complex operations much simpler to write and understand. Rails displays these SQL statements in development mode to help engineers understand what's really happening under the hood. It's great for learning, and while it may be hard to understand initially, with a bit of practice, it can be a really useful tool to making sure queries are as efficient as possible. That's a good start, but Zoe wanted to understand how ActiveRecord works within Rails. She identified 4 main areas in her app to explore: gem file, default configuration, database configuration, and model generation. Zoe starts with the gem file, but before heading to the gem file, she wanted to confirm exactly what a Ruby gem is. A Ruby gem is code that's been written for a specific purpose that can be used in anyone's application, so they don't have to write it all themselves. In fact, when Zoe ran Rails New to create her Rails app, a lot of gems were included by default. Zoe learned that anyone can create a gem and commits herself to writing one in the future. RubyGems.org is a site where you can find, install, and publish Ruby gems, just like it says. Satisfied, Zoe heads to the gem file in her Rails Girls application. The first thing Zoe notices in the gem file is the source on line 1. This indicates that all the gems will be retrieved from RubyGems.org, the site she was on. If Zoe ever wants to update her gems or add any new gems to her application, she'll need to make sure she's connected to the internet. If she needs a gem that isn't on this site, she could specify the website to retrieve it from for that specific gem. Zoe finds the gem Rails and sees that it adheres to semantic versioning, where each version number consists of 3 parts: major 8, minor 0, and patch 1. Zoe ventures back to the rubygems.org site to see what her specific gem looks like. She can see that there are a lot of dependencies, including ActiveRecord. Each of these dependencies is its own gem, and each one is a component of Rails. When she uses Bundler to install her gem, Zoe can expect an ActiveRecord gem version 8.0.1 to be installed, which she would be able to see in gemfile.lock. Gemfile.lock keeps track of all the gems being used in her application, with a specific version for each one. There's a lot going on in gemfile.lock, but she does a search in the file and finds the first instance of ActiveRecord. Surprisingly, the version written here is 8.0.2, not 8.0.1. Zoe heads back to the gem file to confirm she's remembering correctly. Yep, 8.0.1, but what she missed before is the tilde and greater than sign. This means that her app can use any Rails version that is greater than or equal to 8.0.1 without going into the next minor release, the second number. So 8.0.0 would never appear in gemfile.lock because the patch version, the last number, is too low. 8.0.2 could, which is what it currently is. However, 8.1 would never appear as it's the next minor release. That explains why the versions are different between the gem file and gemfile.lock. Another quick look at gemfile.lock, and Zoe understands its importance. At the time of creating her Rails Girls app, Rails Gem 8.0.2 was used, and this version was saved in gemfile.lock. Now, anyone who wants to collaborate with her on her Cody ideas can run bundle and will be working off the same Rails version, even if 8.1.0 is available. Neat. In her exploration of the gem file, Zoe learned that the Rails gem was automatically added to the gem file when she ran Rails New. The Rails gem has many dependencies, including the ActiveRecord gem. Even though ActiveRecord isn't listed in her gem file, she can see that it exists because it's listed in gemfile.lock. The pieces of the puzzle are starting to come together. Next is default configuration, and for this, Zoe dives into application.rb. Zoe hones in on line 3, require Rails all. Rails, she knows, is a modular framework composed of various components, and she saw that each component is its own gem. Each component is responsible for different aspects of web development. These components include ActiveRecord for database interaction, the main focus for Zoe today, Action Mailer for email handling, ActiveModel for validations and callbacks, and a bunch more. Zoe learns that you can in fact omit this line of code and require each of the components individually if you didn't need all of them, but by default, they're all included. Zoe notices, though, there's no all file in her Rails application. Turns out, to find Rails/all, you have to go right to the source, the Rails source code that is, and look for a file called all.rb. Here, Zoe sees an array of all the different Rails components, written as strings. Each of these strings maps to a folder in the Rails codebase, and inside each folder is either a rail tie or an engine file. The one Zoe is most interested in is on line 6, ActiveRecord/railtie. Rails goes through this list, and for each component, including ActiveRecord, it loads its rail tie. The rail tie is what connects the component to the rest of the Rails app. The code in railtie.rb sets things up so ActiveRecord can hook into the boot process and generally play nicely with the rest of the framework. This file requires ActiveRecord, which loads the core object relational mapping, ORM, functionalities like models, queries, and associations. So, it all started in application.rb, where Zoe saw that the app requires Rails/all. This is Rails' way of saying, I want to use all of the framework's modular components, ActiveRecord, Action Mailer, ActiveModel, and so on. Then, Zoe followed that line of code into the Rails source code and looked at all.rb. In this file, Rails goes through each of the components, including ActiveRecord, and loads its rail tie. Still in the Rails source code, Zoe followed the trail into ActiveRecord's rail tie file. Inside that file, Zoe saw require ActiveRecord. This means, now that ActiveRecord is wired into Rails, go ahead and load its core functionality, the models, the query methods, the validations, everything that makes ActiveRecord ActiveRecord. By having the line require Rails all in application.rb, Zoe is loading ActiveRecord and loading all the Rails-specific setup it needs to work properly inside of her Rails Girls app. Surprise, she's already at this halfway through. Zoe forges on to the next item, database configuration, and heads to database.yaml. This file, Zoe learns, is essential for specifying how ActiveRecord should connect to her database. She sees that this file is organized into different sections for different environments: development, test, and production, though these keywords could be changed and could be anything. There's also a default section, and Zoe sees that all her environments are inheriting their configuration from the default. The only unique attribute is the database name. She learns that line 8 is specifying the database adapter that ActiveRecord should use to connect to the database. Zoe's out-of-the-box Rails setting is using SQLite, but she could come back here and change this if she wanted to use a different one. For example, to use PostgreSQL, she would need the PG gem installed, and if she wanted to use MySQL, she would need the MySQL 2 gem installed. Zoe notices a comment above that indicates she'll need the SQLite gem installed to be able to use the SQLite adapter for the database. A quick look back in her gem file confirms that the SQLite gem is there, which makes sense because her application works. SQLite 3 is another gem that was included in the gem file when Zoe ran Rails new. Zoe adds pool and timeout to her explore later list and heads to the database keyword on line 13. In the case of her development environment, the database is stored as a file locally. The database keyword specifies the path to the SQLite database file. A look in the storage directory reveals that there is indeed the mentioned file. Unfortunately, the file isn't supported in VS Code, apparently, but that doesn't stop Zoe from trying to see what's in it anyways. It looks like this file is a whole lot of nothing, or a whole lot of null, to be a bit more specific, that just keeps going. Zoe does eventually spot some familiar code about creating an idea table with name, description, and picture, and eventually she even spots the text she was looking for before, recreate scene from The Lion King. Zoe needs to know what's going on in this newly discovered development.sqlite3 file, so she hacks in, or at least that's what it feels like she's doing. Armed with commands fresh from ChatGPT, Zoe changes directory into storage and starts a SQLite console to dive into development.sqlite3. It worked, she's in. Zoe should probably start investigating how to be a hacker. Now that she's in, Zoe wants to see what's in there, so writes a command to print all the tables. Interesting. Ideas, that makes sense. That's the table she created. Schema migrations, all right, she's seen these words before. But AR internal metadata, that's a new one. Resolving to stay on track, Zoe writes a command in SQL to print all the rows in her ideas table. She does reflect, though, that if she was in the Rails console, ActiveRecord would enable her to write idea.all, which is much simpler. Yep, that's the data from her ideas table, but the formatting isn't quite as nice. Satisfied, Zoe moves on to investigate what's in the schema migrations file. Not as exciting as she was hoping, but she does recall seeing this number before. She takes a look at the ActiveRecord migration file that was created when she ran the Rails generate scaffold command and sees that this number is at the beginning of the file name. On closer inspection, Zoe realizes that this is actually a timestamp of when the file was created, year 2025, March 14th at 10:39 a.m. and 21 seconds. At least Zoe has an alibi for what she was doing on that day, in case anyone accuses her of being an actual hacker. Since there's only one table left, Zoe decides she might as well take a look in AR internal metadata. She writes the command to print its content and is pretty underwhelmed about the results. She adds AR internal metadata onto her list of things to investigate further and retreats to database.yaml. Back where she started, Zoe realizes that even though there's nothing obviously ActiveRecord specific in database.yaml, this file is crucial for making sure her app and database can talk to each other. When our application boots, ActiveRecord reads this file to figure out which adapter to use, SQLite 3 in this case, which database file to connect to, like development.sqlite3 in development, and other important connection details too. Holy heck, we're at the last topic, model generation. And for this, Zoe dives into ActiveRecord.rb. But first, let's review what Zoe did at the Rails Girls event. She ran Rails generate scaffold with the table name idea, then the attributes with their types, name string, description text, and picture string. Running Rails generate scaffold created a migration file to create her ideas table. A migration file tells Rails how it should change the database, in this case, creating an ideas table with name, description, and picture attributes, and also some timestamps. At this moment in time, nothing has happened to the database. Zoe could make any changes to the migration file that she wants to see reflected in the database. Then, Zoe ran Rails dbmigrate. This command runs any migration files that haven't been run. But how does Rails know if a migration file hasn't been run? Turns out it's the schema migrations table that's in charge of this. If the timestamp of the migration file appears in the schema migrations table, then Rails knows that the database changes in the migration file have already been applied, so it won't do them again. If the timestamp of the migration file does not appear in the schema migrations table, then Rails will apply the changes to the database from the migration file and then add the timestamp to the schema migrations table. It's all starting to come together. So Zoe ran Rails dbmigrate. Rails checked that the timestamp from the migration file wasn't in the schema migrations table, and then applied the changes to the database. Because Zoe used Rails' handy scaffold command, Rails created idea.rb. It also created some other files too, but she's not very concerned about those today. Zoe heads back into the code and starts with her idea class. She did add a couple of validations to this class. She wanted to make sure that all her ideas have a name, and she didn't want to accidentally repeat herself, so she used ActiveRecord's presence and uniqueness validations on the name attribute. Zoe sees that her idea class is inheriting from application record. This means that Zoe's idea class will get access to all the methods and attributes from application record, kind of like a puppy inheriting traits from a parent in real life. A look in her file directory, and Zoe sees that application record is the only other file in the models folder, an easy win for exploration. At first glance, it doesn't look like her idea class is inheriting that much logic from application record. Application record, Zoe sees, is an abstract class. This means that application record will never be called directly, only inherited by other classes, like her idea class. For example, Zoe would not be able to do applicationrecord.all in the console, in the same way she can do idea.all. Well, that doesn't mean to say she can't do it. She did try, but the results weren't great, and she was informed that there was no such table. Back on track, Zoe learns that application record is the base class for all of the models in her application. If there's any logic that all her models should have, then that logic could potentially go in here. Application record is inheriting from ActiveRecord base. This inheritance is what turns what would be a regular Ruby class into an ActiveRecord model. In Rails, ActiveRecord base is the primary class that provides the core functionality for interacting with a relational database. Magic happens in ActiveRecord base, or at least a lot of really cool code that's very easily accessible to all of us on GitHub. So it's off to the Rails source code to do some investigating. In the Rails source code, which is starting to feel like an extension of our own application, Zoe sees that base.rb is a pretty big file at 337 lines, and a lot of files are being required. When Zoe scrolls down, she sees that there are a lot of comments and adds a note to herself to read these later. After all, somebody probably spent a lot of time writing these for a reason. After much scrolling, she gets to the start of the base class and sees that this file extends and includes logic written elsewhere. Interesting. Feeling a bit overwhelmed at the large list, Zoe decides to focus on validations, something familiar. She decides to see if she can find where the code is written for the presence validation that she's using in her app. After all, the Rails source code, though at first magical and mysterious, is also just code written by humans, or AI. One can never be too sure these days. Armed with a specific goal, Zoe finds validations.rb, which is included in base.rb, and heads there. In validations.rb, Zoe searches for the presence keyword, not wanting to get too sidetracked, but of course adds read comments in validations.rb to her to-do list first. She finds presence at the end, and it seems that this too is being required. Presence.rb can be found in the validations folder. Presence.rb is the end of the line. Made it, she thinks. Zoe skims the comments and is surprised at how little code is actually written in this class. But it's not quite enough for her. Zoe wants to see it in action. Where does the validation really happen when she tries to create a record? Time to head to the console and find out. When Zoe tries to create a new idea without a name value, it shouldn't save to the database because of her presence validation. She's calling the create method with an exclamation mark after it, which is referred to as a bang, and that means ActiveRecord will report back with any validation errors. Zoe runs the code, and like an over-eager engineer, ignores the colorful font and skips right to the end of the console output. Validation failed, name can't be blank, invalid. As expected. But maybe that colorful font is worth exploring, since Zoe does want to dive deeper into ActiveRecord validations. From the top then, transaction begin immediate transaction. This is a solid mix of ActiveRecord and SQL working together. ActiveRecord has wrapped Zoe's create method in a transaction to ensure that either everything is saved or nothing is. No half measures here. So Rails begins the database transaction to create a new idea record, and it does so immediately. Immediate is the part where ActiveRecord collaborates with SQLite. Immediate means that no other connections will be able to write to the database until Zoe's database transaction is finished. So, if Zoe was midway through creating an idea object, and someone was simultaneously trying to create a new idea on the website, the idea from the website wouldn't be able to start its transaction until Zoe finishes her. SQLite also offers differed and exclusive options, which Zoe plans to experiment with later on. Okay, that's line 1. On line 2, there's a SQL query, checking in the database to see if there are any idea records that have a name value the same as the one Zoe is trying to save. If we remember back to Zoe's idea model, she was concerned about having the same idea twice, so she added in uniqueness validation on the name attribute. Even though Zoe's trying to create an idea with a name value of nil, the validation still checks to see if there's an idea record with the name of nil, but that really shouldn't be possible unless someone does some sneaky stuff. In the final line, the transaction is rolled back. Zoe already saw the reason on the next line, but is surprised there's no warning in the rollback transaction line. Zoe needs more information. She's seen the SQL query that checks the uniqueness validation in the database, but why is there no output about presence validation? And where does this validation message come from? How does it even all work? While looking at the Rails source code is super helpful, Zoe wants more control. She wants to be able to see where calls are being made and do some exploring. Zoe starts from the bottom up in ActiveRecord's presence.rb. She decides to recreate this file with the validate each method in her Rails girls application within her lib folder directory. She adds in a debugger statement so that she can confirm that this class will be called when she tries to create an idea record. To make sure this new file is included when she tries to save an idea to the database, Zoe requires this file in her idea model. She restarts her Rails console to make sure the file is loaded and tries to create an idea without a name, hoping the code stops at her debugger. Success! Zoe's debugger being hit confirms that this is definitely where validation happens. Although, Zoe doesn't really see anything that is checking presence. It seems that this class is actually inheriting logic from ActiveModel, validation's presence validator. Very sneaky, and also classic Rails. Zoe types continue and sees the same error as before. New plan. Zoe recreates ActiveModel, validation's presence validator class, which has a validateEach method in her lib folder directory. This validateEach method looks like the one she was looking for. Zoe can see that an error is being added to the record, but only if the value is blank. Feeling optimistic, Zoe requires this new file in her idea model and starts a console to create an invalid idea. She hits the debugger that she hit the first time, which makes sense because this class is inheriting from the ActiveModel equivalent. Continuing through the flow should mean that she ends up at her next debugger statement. And it does. Zoe has found where the presence validation logic actually lives and is surprised to realize it's not in ActiveRecord, it's in ActiveModel. This means that Zoe can use validations even outside of the database layer, like in form objects or API-only applications, which is super handy. Zoe decides to have a little explore now that she's stopped in the validateEach method. She starts with record and sees what it is in the console. Record returns a recorder for thread, and record.class returns an idea class. Next is at her name, and when Zoe looks at this in the console, she gets the name attribute. This makes sense. It's the only attribute that has the presence validation. Then Zoe looks at the value parameter that's passed in. The value is nil, which is expected, and also returns true when she checks value.blank. This means that Rails will be adding an error to the idea record with the attr name of name, a blank symbol, and options. Options, Zoe confirms, is an empty hash. Zoe takes a moment to step back and regroup. It's easy to lose track of time in the Rails codebase, but she's conscious that, as riveting as this is, lunchtime is fast approaching. The goal is to figure out how ActiveRecord validates a record. So far, she knows that because of her presence validation, she's going to hit the validateEach method in ActiveRecord validation's presence validator, which will then hit the same method in the ActiveModel equivalent. Zoe decides to recreate all of the files that she thinks are the most relevant to validating a record in the database, adding in debuggers to confirm the flow. She creates a local copy of ActiveRecord persistence with the create and save methods, both with a bang and each with their own debugger. When Zoe runs idea.create in the database, she's expecting to stop at the debugger statement in the create method and then hit the save method. Surprisingly to some, including Zoe, the call to object.save is not hitting the save method in ActiveRecord persistence, at least not yet. It's going to hit the save method in ActiveRecord validations. Zoe also adds in perform validations and the valid method, each with their own debuggers. Zoe will stop at the debugger in the save method and then perform validations. Since there will be a validation error, Zoe's confident that the ternary operation will result in raise validation error. In perform validations, Zoe hasn't passed in any options, so she'll move to the valid method, and then in the valid method, she'll hit super, which in this method should lead her to the valid method in ActiveModel validations. Zoe recreates ActiveModel validations with the valid and run validations methods, each with a debugger. In the valid method, the code leads to run validations. In run validations, Zoe sees run validate callbacks. This is dynamically defined by Rails using active support callbacks. Zoe has to do some digging, but she eventually figures out that run validate callbacks should lead her to ActiveModel each validator. So Zoe recreates it and adds in a debugger just before the validate method loops through all of the attributes on the record. From here, Zoe's expecting that the validateEach method will lead her to the validateEach method in ActiveRecord validation's presence validator, which is where she initially started, and where she already has a debugger. Lastly, from here, the call to super and the inheritance will lead Zoe to the validateEach method in ActiveModel validation's presence validator, which still has a debugger. Before Zoe can test out her new flow, she needs to require the 4 new files in her idea model. Now it's go time. Zoe starts up a new console session and tries to create an idea with a name of nil. She hits her first debugger in the create method of ActiveRecord persistence class methods, as expected. She continues, and then lands in the save method of ActiveRecord validations. Zoe's got presence and uniqueness validations on her name attribute, so her next stop should be in perform validations, and it is. Zoe hasn't passed in any options, so the next stop should be in the valid method just underneath, which we'll then call super and head to the valid method in active model validations. From here, Zoe expects to land in the run validations method, which will then land through Rails' dynamic declaration of run validate callbacks, land her in the validate method of active model each validator. From here, Zoe is on familiar, or at least recently explored, territory. Rails will call the validate each method for every validation applied to an attribute. This lands her in ActiveRecord validation presence validator, which then takes her to the real source of the logic in active model validation presence validator. From here, it should be to the validation failed message she saw the first time. Oh, Zoe lands back in active model each validator. A bit surprising, but when she checks which attribute is being looked at, it makes sense. This would be the uniqueness validation she added on name. Okay, now she should see the validation failed message. Back in each validator again. Weird. Zoe checks which attribute is being validated and is surprised to see the picture attribute. She continues, expecting the failed validation message, but is still in each validator. And the attribute being validated? Still picture. She doesn't know what to expect. She didn't write any validation for picture, but it's back in each validator again. And once again, we're looking at picture. This just doesn't make sense. On continuing, Zoe has never been so pleased to see a validation failed message. That flow went somewhat to plan. Checking in her idea model, Zoe confirms that she definitely hasn't added any picture validation, but code doesn't lie. There is validation somewhere. She writes a command in the console that will output all the validator classes on her picture attribute and finds the culprits. Carrier wave is a gem Zoe added to handle the logic for uploading a picture. It seems that the carrier wave gem has its own sneaky validations in its logic that are being applied to the picture. Interesting. So, what did Zoe's investigation discover? When she ran idea.create, she hit ActiveRecord persistence class methods create method, which then led to ActiveRecord validation save, then perform validations, and then valid. This led her to active model validations valid, and then run validations. From here, she went to active model each validator validate, and then went to the validate each method in ActiveRecord validations presence validator, and finally to the active model equivalent of validate each. It was in here that validation failed because name was nil. So the save method returns the validation errors rather than saving the record to the database. But what if there hadn't been a validation error? How would ActiveRecord create a new record in Zoe's SQLite database? Zoe knows she's running out of time, but she's too excited to find out how ActiveRecord saves a record to the database to stop her journey here. To speed things up, she comments out the debugger statements in all the new classes she added, except for the first two, create in ActiveRecord persistence class methods, and save in ActiveRecord validations. Thankfully, Zoe already has all the files she needs. There are only a few more methods she needs to add to ActiveRecord persistence. Zoe knows that when she creates an idea, this time with valid attributes, she'll hit the save method in ActiveRecord validations. This will lead her to the save method in ActiveRecord persistence, where she already has a debugger from before. From here, Zoe expects to hit the create or update method, where she's added a debugger. And since she's creating a new record, not updating one, the next stop should be in the create record method. There's a lot going on in the create record method, so Zoe adds explore create record method to her to-do list and pops in a debugger in the block that uses a connection. Zoe has suspicions about what the connection could be, but wants to confirm to be sure. We're one method away from the code that adds a record to the database, and that happens in insert record. Insert record, the last method for today in this presentation, with one last debugger statement. Zoe skims the code, adds insert record method onto her learning to-do list, and spots connection.insert at the bottom of the method. This is the magic, or code, for adding a record to the database. Okay, one last run through in the console. Zoe's in a fresh new console, so her new methods are available, and writes the code to create a valid idea. Her first stop is in the create method, same as before, and then she continues into the save method of ActiveRecord validations. This is where things get new. She's not expecting any validation errors, so the call to super should lead her to the save method in ActiveRecord persistence, and it does. All good so far. Next stop should be to the create or update method, which it is. And then, since we're creating, not updating, we should hit the create record method in ActiveRecord persistence class methods. Amazing. Zoe pauses to check which database adapter is being used inside the create record method. She confirms that connection is the SQLite 3 adapter. This matches what she saw earlier in database.yaml when she was investigating the adapter settings. Now she knows when Rails talks about connection, it's referring to this adapter instance. From here, Zoe hits the last method, insert record. This should be the end, all going well. An idea should now be inserted into the database. And it is. Zoe can see the SQL output where a new idea is inserted and the database, and that a database transaction was committed. Who knew that creating a record in the database could be so exciting? Okay, that was a lot. Zoe takes a moment to regroup and confirm what happened. She tried to create an idea in the console, this time with valid attributes, and hit ActiveRecord persistence class method's create method, and then ActiveRecord validation save, same as before. Since she removed all the debuggers from the validation flow, and since there weren't any validation errors, she went straight to ActiveRecord persistence save, then create or update, and then create record. Zoe paused to confirm that connection was SQLite 3 adapter she saw in database.yaml and was pleased to have her suspicions confirmed. There was one final stop then in ActiveRecord persistence class method insert record, where her ideas were inserted into the database. Time to sum up Zoe's exploration of model generation. She used Rails' handy generate scaffold command to create all the files she needed, including her idea model. Once she checked her migration file was good to go, she ran Rails dbmigrate, which applied her changes against the database and added the timestamp to the schema migrations table. Then she took a look at her idea class and saw that it was inheriting from application record. When she looked at application record, she saw that it was inheriting from ActiveRecord base. Then Zoe ventured back into the Rails source code and saw that base.rb requires, includes, or extends all the files that bring in the functionality she uses on the daily when working with her models and databases. She could have stopped there. She found the base, literally, for ActiveRecord. But instead, she did a deep dive into the source code, where she looked at several classes in ActiveRecord and ActiveModel. Did Zoe look in every method touched when a record is created or validated? Definitely not, but this was a solid start. Zoe is feeling like she has a much better understanding of the role ActiveRecord is playing in her web application and how it comes out of the box with Rails. In her gem file exploration, Zoe learned that Rails is a gem that's added to the gem file automatically with the command Rails new. And importantly, one of the dependencies of the Rails gem is the ActiveRecord gem. In default configuration, it was in application.rb, where the line require Rails all loaded all the Rails components, including ActiveRecord, via railtie. In database configuration, Zoe realized that there's nothing specific to ActiveRecord in database.yaml, but you do need a database adapter for ActiveRecord to be able to connect to the database. And she learned how to hack in to her development database, so that was a win. And finally, in model generation, it was an application record, which inherits from ActiveRecord base that turns what would be a regular Ruby class into an ActiveRecord model. When Zoe investigated ActiveRecord base in the source code, she saw all the logic that is required, included, or extended in the class, and realized that ActiveRecord is much, much more than just a translator between her Ruby code and her SQLite database. Zoe figured out how to bring the Rails source code to life in her own application, to understand the classes and methods that are being used to validate and create a record in the database. And she decided that if ActiveRecord had a best friend, it would probably be ActiveModel. This marks the end of Zoe's ActiveRecord learning for today. She's excited to spend more time working on her Ideas app with her improved understanding of what's happening behind the scenes. She's also got a big ol' list of items to learn more about that she created on this ActiveRecord journey. Thanks everyone for listening. You can find the repo for this presentation on my GitHub account if you want to test out some of these debuggers at home. I personally love a debugger statement. If you want to connect, you can come and say hi after this talk, or find me on X, which I don't really use, and LinkedIn, which I use a lot more. My mom very kindly gifted me with a very popular name. I've even met someone named Jessica Marie Sullivan, so I've included the URL there in case you want to connect. Now, I make that lunchtime.